Now, welcome to you. Our new topic will be to find the arrest the product of two quantities. So we have two quantities A and B, and their product is Z. So here the errors in A is delta A and errors in B is delta B. So delta A and delta B are the absolute error. This is known as the absolute errors. Absolute errors in A and B respectively. A and B respectively. Now the measured value, how to measure, if you measures, suppose we have measured the value of A, the measured value will be A plus minus delta A in A and also B plus minus delta B. So these are the measured value, in A and B respectively. So it means that our measured value, when you measures this quantities A and B, so our measured value will lies between them. Maximum will be, if I write the measured value in terms of this one, maximum will be A plus delta A, quality is also this one, and minimum will be A minus delta A. So it means that our measured value will lies between these two values. So similarly for this is the quantities B plus minus delta B for B. So now we need to calculate the measured value. What will be the errors in Z? So let us start. So here we can write Z plus minus delta Z is equal to A plus minus delta A multiplied B plus minus delta B. If you simplify it and using Z is equal to AB, just multiply it. First multiplied A, this term by A dot B plus minus A times of delta B, and second case you multiplied this delta A, this is delta A times of this one. It means that plus minus B times of delta A, and plus minus delta A times delta A times delta B. This will be our delta A times delta B. Now divide the whole term by AB. If I divide the whole equations by AB, dividing by A dot B. Since A dot B is equal to Z, so we have to divide left hand side by left hand side in terms of Z, left hand side by Z and right hand side by AB. So it will becomes Z plus minus delta Z divided by Z is equal to divide right hand side by A dot B. A dot B and plus minus A delta B divided by AB and plus minus B delta A divided by AB and plus minus delta A delta B, delta A dot delta B divided by A and B. Now by simplification, Z upon Z will be 1 plus minus delta Z upon Z, and it will becomes 1, and here A cancel out and it will be delta B upon B, and B cancelled, plus minus delta A upon A, and here plus minus delta A upon A dot delta B. Dot means the product. Yes, here left hand side it will be cancelled out. Now here delta A, delta B, this is very small quantities. So delta A known as the relative fractional error, delta A upon A known as the relative fractional error, and similarly delta B and B is the relative error since B. Since these two values are very small, then their product tends to 0. Now our new value becomes plus minus delta B upon B and plus minus delta A upon A. So if I organize this, the maximum error should be both positive and both negative, will be delta Z upon Z. This is known as the relative fractional error, plus minus delta A upon A and plus delta B upon B. So this is the maximum, this is known as maximum fractional error. This will be maximum fractional error. So in the final product with Z, the maximum fractional error should be added. The maximum fractional errors of A, the fractional error of A plus fractional error B will be your net fractional error of Z. Next we will go finding the errors in the quotient of two quantities. I mean we have to find the errors A divided by B. Now our next topic is error in the division of two quantities. We have two quantities A and B. Their division is A upon B, also known as quotient of result is A upon B. Suppose the quotient of A upon B is Z, that is the quotient of A upon B, also known as A divided by B. So we need to calculate the errors in A by B. So we already discussed the errors, absolute errors in A is delta A and B is delta B. So the errors in Z will be Z plus minus delta Z. This is the calculated errors with absolute errors in Z with the alpha of A and B. Now putting the value of A and B here, A plus minus delta A divided by B plus minus delta B. If I take A is common from numerator and B common from the denominator, it would be 1 plus minus delta A divided by A and divided by B 1 plus minus delta B divided by B. So now in equation A upon B is Z, we have to replace A upon B by Z. Now therefore Z replaced A upon B 1 plus minus delta A upon absolute error in A divided by 1 plus absolute error in B divided by B. Now we have to take this denominator part in the numerators and then expand with the help of the binomials. Now it becomes Z in bracket 1 plus minus delta A upon A with the bracket 1 plus minus delta upon B. Since its power is 1, if it goes in the numerator it becomes minus 1. So 1 plus minus delta B upon B and power would be minus 1. Now we have to expand it binomially. You know, by the formula of the binomials, 1 plus x raised to the power minus n is equal to 1 minus nx plus n into n plus 1 divided by 2 factorials, and this goes on. Now we have to use only up to the first two terms, first two terms. So in that case the value become z plus minus z will be z, first term is z multiplied to 1 plus minus delta absolute error in A divided by A. Now binomially expands, its power is 1 plus minus delta B upon B has the power minus 1. This minus 1 goes here, so it becomes 1 minus plus delta B upon B and other smaller terms. Now if the x is very small, so we can exclude after these terms because they are very small, they are negligible, x square very negligible and x cube also negligible. So I have now taken beyond the first two terms, beyond the second terms. Now after multiplication, if you multiply this one and divide by z, if I divide the whole thing by z, it will becomes 1 z upon z. Now here this value becomes z divided by z plus minus delta z upon z. I have divided by z. By dividing z, now make a simple calculation after multiplication. First multiply 1 multiplied this becomes 1 minus plus delta B upon B. Now multiplied plus minus delta A. This is plus minus delta A with this, so it becomes plus minus delta A upon A into 1, and next ones multiply these two terms, it becomes plus minus delta A upon A dot delta B upon B. Now z upon z is also 1, this term should be cancelled. Now finally we have plus minus delta z upon z, and first write this and this plus minus delta A upon A and minus plus delta B upon B. Since the product delta A delta B are very small quantity, therefore the product of these two quantities should be negligible, should be tends to 0. So therefore we neglect this value because this is not very big quantity, so I have deleted from here. So now the maximum, this is the value of this one, we need only the maximum errors, errors in z. So maximum errors in z, so we have to consider only the maximum error in A and B. Since this is delta A upon A, so such type of quantity known as delta A upon A, this is known as a fractional error, known as the fractional errors. Also delta B upon B and also delta Z upon Z. All are the fractional errors. All are the fractional error respective quantities. This is the fractional error A, and this is in V, and this is in Z. So all are the fractional errors. So we need only the maximum fractional error. So the maximum fractional error will be here. So plus minus delta Z upon Z is equal to plus minus taken out, so delta A upon A plus delta B upon B. Therefore our maximum fractional error will be in this calculation delta A upon A and plus delta B upon B. Now we can write plus minus outside of this one. Now in the combination of errors, next article is error in the power of a quantity. Now let us suppose we have a quantity A, its power is n. We need to calculate the errors in a की power n. Let us suppose that quantities after calculation comes out z. Z is equal to a power n. So so let us suppose the measured value in a is a delta a plus minus delta a. This is the measured value in a. So this value gives you the range. This value gives you range. It means that the measured value will come out in this bracket, in this interval a minus delta a to a plus delta a. The measured value will be lies between these intervals. So we need to calculate here. So now the errors in the nth power of a z plus minus delta z. Delta z will be the absolute error in z, and delta is the absolute error in a. Now a plus minus delta a raised to the power n. So we have a formula here: 1 plus x raised to the power n by expanding binomially by binomial expansion. Binomial expansion, it would be one plus nx plus n into n minus 1 divided by 2 factorials x square, and next term would be n minus 1 n minus 2 divided by 3 factorial x cube, and it goes on. It will never ending. It goes to infinite. So if I suppose that if I x is very less 1, if here x less is 1, then the quantities after nx, after this terms x square, x cube, and x raised to the power 4 and so on will be very small. So we can neglect after the second term. So our value becomes 1 plus nx. So that's why we have taken only the first two terms. Same thing is here. So delta is very small. So we have to expand only the first two terms. Now applying the binomial expansion is here also. A plus minus n multiplied delta a. So this is the value after applying this formula. So now if I divide the whole term by z is equal to a raised to the power n, and dividing by z is equal to a raised to the power n. In left hand side we have to divide by z, right hand side we have to divide by a raised to the power n. This becomes z plus minus delta z divided by z is equal to a plus minus n times of delta a divided by a raised to the power n. We have to make some correction each year. I think there is need some corrections. First we need we have to place easier one, then only when you apply the binomials. We can also apply in that case, but it will be easier if I write one is here. First taken a outside of this one, so taken a is common. If I bring a outside from this bracket, it becomes a raised to the power n. Inside will be a plus minus delta a divided by a raised to the power, and now we have to apply the binomial expansions here. Now the binomial expansion becomes a raised to the power n. Only here 1 plus minus it should multiply n times of delta a upon a. So it is after applying this binomial expansion, a times of nx, a plus x, and this is the same one, and a plus x, our x will be this one. So we have to write this one, make some corrections. So now the whole quantity is here, should have also changed here, a raised to the power n 1 plus minus n times of delta a upon a. We have to divide this quantity, this equation, left hand side by z and right hand side a raised to the power n, so that respective terms should be cancelled out. We have to divide right hand side by a raised to the power n, since z is equal to a raised to the power n. So now a की power n is cancelled out. Now just do it, and breaking this, z upon z is 1 plus minus delta z upon z is equal to 1 plus minus n times of delta a upon a. So now 1 is cancelled out. Finally we have delta z upon z. The maximum error becomes n times of delta a upon a. We can write plus minus here, is also plus minus here. Now these values become, the fractional error z is equal to n times of delta a upon a. Now this is our answer. So now when the physical quantities are in the power of some values, we have to need to calculate only the fractional error. And next articles we have, there are this z should be the multiples of many other quantities and raised to the power of some other values. So let us go. Now this is our relations, which is z is equal to a raised to the power b, b raised to the power r, and c raised to the power n. We have to find out how to calculate the errors in this relation. We need to take a logarithm and then differentiate it. Now first differentiate both the sides. First we can go taking the logarithm both the side, then differentiate it, then we will be able to find the relative errors in the physical quantities, in the quantity z. Now taking the logarithm both the side. Now if you take logarithm both the side, take log both the side, so it will be log of z is equal to p times of log of a plus r times of log of b minus n times of log of c. We have the formula for I have applied the formulas here. Which formula? So these are the three formulas. First one, a cross b. If I put the logarithm formula here, log a plus log b, the first one, and log a upon b, log a minus log b, second one, and third one is in the power of a. Suppose a raised to the power n, its a logarithm becomes n times of log of a. So I have applied these three rules in that case. Now differentiate both the side. Now differentiate both the side. Now it will become differentiate of z is in terms of the differentiation, it will be 1 upon z and into dz. Same way p times of dA upon a plus r times of dB upon b, and this is a minus n times of this is dc upon c. So if I write in terms of the fractional error, we can write this in this way: delta z error, absolute error in z divided by z is equal to absolute error in a will be this one. Same way, absolute error in r, absolute errors r times of del b upon b. We have to take only the maximum absolute errors, maximum fractional error. So here if I take both if I consider both the values, we have to write plus minus. Here is also plus minus n times of del c, fractional error in c. Now we need only the maximum fractional error, so we have to take only the maximum fractional error, whether it is positive and negative, but magnitude should be the same, only the amount would be negative. Now the maximum fractional error will be here. Delta z upon z, taken only all positive one times and all negative one time. So if I take only the positive value, it will be p times of delta upon a plus r times of delta b upon b and plus n times of delta c upon c. If you take all negative value, the negative value should minus and minus and minus. So in magnitude, both positive and negative will be the same ones. So in this way, in these relations, this is, if there is the products and division, also the raised to the powers, in such cases we have to using this formula. It is a ready-made formula. Using this relation, we can use we can apply this in the finding the errors in the resistances, resultant errors in resistances in series and in parallels. Let us discuss one by one. This is the questions we need to find the errors in the combination of two resistances. One is in series. Let us suppose that this is R1 and this is R2. They are connected in series. Now their resultants will be R1 plus R2. We already know the errors in the sum of two quantities. These are the two quantities. So therefore the absolute errors R will be absolute error in R1 plus absolute error in R2. And now what will be the errors in parallel? When these two resistances are connected in parallel, then what would be the errors in finding this? So now suppose this is R1 and this is R2. We already know that when the resistances are in series, not in series, when the resistances are in parallel, then resultant will be R, and it will be written in this way. So now in that case, for finding the errors in when the resistances are in parallel, we have to differentiate this one. We need to differentiate this one by the method of differentiation. Now first differentiate this. Differentiations. So now in the differentiations, by applying the methods of differentiation, it would be written like this one: dr divided by minus r square If you differentiate this one, so it will become minus dr1 upon r1 whole square and minus dr2 upon r2 whole square, because we have to differentiate this one. Suppose this is the quantity. If you differentiate this one like this is our value. Now the value is d upon dx. If you differentiate 1 upon x, you bring this x in the numerator, x raised to the power minus 1. So that value becomes minus 1 x raised to the power minus 1 minus 1. So now this value becomes x raised to minus 2. Now this becomes 1 upon x square. This is the rules of the differentiations. So now this is the rules of differentiation. Same thing would happen. 1 upon r had the differentiation minus 1 upon r square. 1 upon r1 had the differentiation minus 1 upon r1 square. So same way 1 upon r2 had the differentiation minus 1 upon r2 square. Now written this value in terms of the fractional error. This is like the fractional error. There are small changes in r. We can write it in terms of the absolute error. This is del r, this is del r1, and this is del r2. Now this value becomes in terms of the fractional error. So this value minus minus would cancel out because all terms have the minus. Del r divided by r square is equal to del r1 upon r1 whole square and del r2 upon r2 whole square. So this is the formula of finding the errors in this formula. When the resistances are parallel, we need to differentiate these values. Or we write here delta r upon r square is equal to absolute error in r1 upon r1 whole square plus delta r2 upon r2 whole square. This is our relations or finding the errors in when the resistances are in parallel.